Hey folks, I'm Jen Foxbot, and welcome to Why Calculus is Cool, Part 2. So in this video, I'm going to talk about integral calculus and why integral calculus is super useful and what it actually means when we're doing integrals. Okay, so just like derivative calculus, I'm going to use a function. And in this case, last time we were dealing with rates of change. And so when we're talking about how things change, the way that humans, I guess, are most familiar with change is time, right? Because time keeps marching forward and things change over time. And so that's an easy way for us to understand derivative calculus. For integral calculus, what we're really doing is finding areas. And so for this one, instead of t being on the x-axis, or, well, haha, I just gave that away. Instead of t being on the horizontal axis, I'm going to put this as x. And instead of, and I'll just do the vertical axis as y. Last time I labeled it x. Again, math is just a series of symbols. It's a language that we use to communicate and to find information. So as long as you follow the rules, you can kind of do whatever you want, which is tight. Okay. So now we also have another function, f of x, and I'll just draw some random curve like that. So that's what f of x is. Well, and our function f of x is y. So basically what this is saying, a function f of x is just saying, okay, for any given value of x, like let's say x is 1, what is the value of y? And so say for example that was 2. Our function, if we plugged in 1 for x, it would give us 2. If we plugged in 2 for x, it would give us whatever value this is for y. If we plugged in 3, etc., etc., etc. So this is how we figure out what y is for a given value of x. And so what integral calculus does, when we take the integral of f of x, you might have seen little numbers here, so like maybe 0 to 10 or something. I'll make it a smaller number, so 0 to 3. So what that means, taking the integral of f of x, is that we are actually adding up tiny little pieces all the way from 0 to 3. So basically, I'm adding up little chunks and summing them together to get the value for this whole area. Whoops, there goes my check. One sec. Okay, hello again. So yeah, so basically what integral calculus is allowing us to do is find the area under the curve. So what this looks like with a simpler formula. Okay. So let's say I just have a line here. And I want to find the area under this line from 0 to 3. So in this case, my function is just a line. So what does that mean? Well, for all values of x, every value from negative infinity to infinity, if we wanted to do that, for all values of x, y equals 2. Whoops, that looks like a z. Y equals 2. And so if we were to integrate 2, let's see, where can I write that you can see? Okay, so the integral from 0 to 3 of 2 with respect to dx, I'm sorry, with respect to x. So what dx is, remember last time when I wrote the delta x and I said that that was just a small change in x? That's really what this is. It's just a different way of representing that. So what dx is a tiny little piece of x. And so when I was drawing those tiny little lines, that's what dx is. Dx is like, we call it infinitesimal, but so you know how like infinite is expanding outward and getting bigger, infinitesimal is shrinking and trying to find like the smallest number possible. So we're talking about like fractions of x. So if you were to write this without using dx, you might say like delta x is 0.1. But you can get a smaller number than that, right? You can get 0.01. And the smaller that your x is in this direction, the more accurate you're going to be. For a flat line, it really doesn't matter how small this is because y is the same. But with that curve, the smaller values of x that you add y up in, that's a weird way to phrase that, but basically the smaller values of x mean the more accurate you're going to be because you're going to hit all of the points of the curve. That might be a little confusing, so I might clarify that in a second. But let me finish this first. So, okay, so we're integrating from 0, from x equals 0 to x equals 3. And we put in our y function, which is just 2, dx. And so again, so 2 is the vertical direction, and dx is the horizontal direction. So basically, dx is how far over do I go before I go up to y and make a little like rectangle. You might have seen your calculus teacher do that. And then how far over again do I go over? And so what's cool is that there are certain rules that you can follow to do this without ever having to figure out how small to make dx. So if you integrate this, you're going to get 2x plus c from 0 to 3. And that basically means we're going to plug in, so c is a constant and x is a variable. So we have to plug in 0 to 3 in for x. So that means we get 2 times 3 plus c. Oops. And then I think you go minus 2 times 0 plus c. And then that equals, we're getting a little low here. So 2 times 3 is just 6 plus c, and then minus 2 times 0 plus c. So then you get plus, well, whoops, minus 0, and then the minus sign carries over, so you get minus c, so the c's cancel out, and you get a value of 6. So then that tells us that the area under the curve, this area, from 0 to 3, is 6. Woo! Haha! So if you notice, we just found the area of a rectangle. What's up? So our rectangle has a width of 3 and a height of 2. So if you use the area for a rectangle, which is just area equals base times height, in this case your base is 3 and your height is 2. Boom! 6. Ha! So with a rectangle, it's fairly easy because remembering the equations to calculate area of common shapes is super well, I shouldn't say super straightforward, but it's easier than remembering things like this. So yeah, if we had a function like that, we could be lazy and just approximate it, but integral calculus allows us to find this whole area, assuming that we have a function for this curve. Yeah, so that's why integral calculus is super cool, because it allows us to calculate areas without having to memorize formulas. And I'm all about understanding versus memorization. Sometimes you gotta memorize, but for the most part, I think it's more important to understand how things work, because once you understand how something works and why we use it and what it does for us, it's a lot easier to memorize because you can connect that with like logic and whatever. Alright, so yeah, the dx thing might be a little weird. I'm going to talk about how to actually do calculus, so I'll probably cover that in more detail in that video, but please let me know if that was confusing or if you have any questions. Alright, so I'm going to leave it there for now. Thanks very much for watching, and I'll see you next time. Bye!